Hello, I want to make a simulation of spring mass oscillator with Matlab. So let's start with an ideal situation where there is no air resistance or friction. The energy of the spring and the mass are conserved. So as you can see here, the energy U is only comprised of the kinetic energy of the block and the potential energy of the spring. And when we take the derivative of the system energy with respect to time, the rate of change of energy is 0. In this case, we get a second-order differential equation like this. But in real life, there's always friction. So let us assume that the rate of change of energy is always is always proportional to the velocity of the block. This is the beta is the frictional constant. So in this case, we get a equation an equation like this. And then we rearrange the equation. Basically, we divide the entire equation by m. So beta divided by m becomes L, k divided by m becomes omega. So this is the general form. I don't know why they do it. It's just what the textbook says. So given the spring constant K, mass, and frictional constant, and also the given initial conditions, position and velocity, we can find out the equation of motion. This is the equation of motion. So why do I need to use Matlab to solve this problem? Because as you can see, this equation doesn't give us anything. We have no idea what actually happened to the oscillation. So because as we know there is friction involved. Let's say here's a spring block system. If we stretch the spring to a position here and then release it, the block should be oscillating. This is time axis. It should be oscillating, but because there's friction, it would be dampering out and then stop at the equilibrium position. So without Matlab, we cannot plot this graph. In this case, I'm trying to use Euler's method to plot the motion. First, what I need to do is so here's the equation I get. What I need to do first is to decompose the second order differential equation, this is second order, into systems of first order differential equation. And then I need to convert the equations into matrix, because that's the only way I can have the equations coded into Matlab. I actually need I actually had to do a little research on this because I don't know why I finished all the calculus. There's not a mention of matrix, so I kind of struggle with this part. Um, so basically, what this part means is I in a matrix S X V. So this is for X is 0x 1V, and then this the second row is negative omega x, and then negative LV, and then I take the derivative with respect to time of the whole matrix. And now I also need to convert the initial condition, initial position and initial velocity into a matrix, into a vector like this. And now I start the computation. So for Euler's method, is given a initial condition. In this case, this is x0. I need to find the slope. The slope is velocity in this case. And also the increment of time, dt. So I can, so with that I can find another point, x1. And then given the x1 with another increment and the slope, the velocity found at x1, I can find x2. Oh, sorry. I can find x2. But then you can see every time I reiterate the computation, the result gradually diverges from the actual solution curve. This is the actual solution curve. But my computed result is diverging from it. So this is the truncation error. This is inevitable. So I would put every consecutive computed result into a vector like this. And in the end, I would also set up a time vector so that I can plot out the graph as position versus time. So as you can see, I first put in all the put in the value for all the variables: frictional constant, mass, spring constant, initial position, and velocity. And then I set up the matrices. Also, the initial condition vector. The increment, I put it as dt equals 0.01. The time interval of interest, I set it as 10 seconds because I assume that the oscillation would have come to a halt in 10 seconds. So, and I try to collect all the consecutive steps into a vector. This is a vector, as you can see here. I try to collect them, and eventually, so that's why I need a for loop. In a for loop, I try to repeat the computation, and every single computation would be collected into vector xf, so that in the end I can plot position versus time. Here I also use another way to plot the oscillation, which is Runge-Carter method. I only use a built-in function, ODE45, because RK4 method is much more complicated. Actually, I haven't even taken differential equation class yet. I have to wait until I go to U of H. All these things I learned by myself. And the end result should be like this. So the initial condition, there's a spring mass. The spring is stretched to this position, and then release, it would oscillate, and because there's friction, it came to a halt at the equilibrium position 0. Thank you.